Alright guys, this is going to be an important one. This one is called power of a product rule. The reason why this is so important is because when your problems get more complicated, this is usually the first step, or a lot of times the first step, not always. So what we're going to have here is a product. You see in parentheses we have a times b. That's a product of two anything. A and b could stand for anything. So we have a product being raised to an exponent. So what do we do when we have a product being raised to an exponent? We allow the exponent to go to each item inside parentheses. So you see how that works here? That becomes a to the power of m times b to the power of m. I'm going to show you how it works with an example and then show you why. So my example here is 2x to the fourth to the third power. So you see on the inside my product is 2 times x to the fourth, then that's being raised to a power. Well, if this is my base, 2x to the fourth, and it's being raised to the third power, that means my base needs to appear 3 times. And this is all just multiplication here. Well, I could rearrange these and I can write all my 2's next to each other and all my x to the fourth next to each other because it's multiplication and I'm allowed to switch things around and do it in any order. So I really could rearrange this to look like this. And what I see here is 2 times 2 times 2. That's a 2 that repeats 3 times. This is going to turn into 2 to the power of 3. This right here is an x to the fourth that appears 3 times. So that's going to be x to the fourth to the third power. Now, if you watched my last video, you saw what happens when I have a power raised to another power. When I have a power raised to another power, I multiply them. So this is really going to be 2 to the third times x to the 12th in the end. And if you want, you could turn that 2 to the third into 8, because we know that. That's easy enough. We could say this is 8x to the 12th. Now, are you going to have to expand it and do it that way every time? No. Here's the nice shortcut. This exponent is almost like the distributive property. What happens is everything inside the parentheses is going to be raised to that exponent. So I'm taking my exponent, and that becomes 2 to the third. And I'm taking my exponent here, and I skip a couple steps. It's x to the fourth to the third, and now we're jumped all the way down here. And I still have to use my power to a power rule and multiply them out. But it saves you a lot of time knowing that you can distribute the exponent. All right, now that you know how it works, let's do a couple more complicated examples. Got one written down here. I'm going to do -4 r to the 6th s to the 15th all to the power of 4. So we got a little bit bigger numbers here, a negative, and one more extra term. But it's still going to basically work the same way. I can still apply the exponent to everything on the inside. So that's going to go to the -4, to the r to the 6th, and s to the 15th. So that gets rewritten like this, -4 to the 4th times r to the 6th to the 4th, and s to the 15th to the 4th. This is how the power of a product rule leads into the last one, power of a power. Right here, I have a power raised to another power. 6 times 4, I multiply them together. This becomes r to the 24th. And with the same thing with the s, I have a power raised to another power. I can multiply them together, and this becomes s to the 60th. Now, it depends on what you're asked for. You might be able to just leave it -4 to the 4th power. If not, you're going to have to do the multiplication. -4 times -4 times -4 times -4. Well, -4 times -4 is 16, times another -4 times -4 is 16. We're going to end up with a positive 256. You can check me on that if you need to. Basically, just again, you can see how the exponent gets distributed to everything inside the parentheses. Let's try one more. some textbooks or some questions will be a little tricky, and they'll show you kind of a little geometry with these problems. So sometimes you might see a problem like this. Pretend that's a perfect square. So if they gave you a square and they gave you a side length, and for some reason this side length is 9c to the 6th d. And they're going to tell you to find the area. Well, if I have to find the area of a square, all we have to do is length times width, or since they're the same, we can do side times side, which is also the same thing as side squared, right? Area is equal to side, the side length, squared. Well, in this case, our side length is 9c to the 6th d. So we're going to have 9c to the 6th d squared. I'm using my power of a product rule because I have 9 times c to the 6th times d. That's a product inside parentheses. I'm going to apply the exponent to everything on the inside, and I can solve for my area. This is going to be 9 squared, c to the 6th squared, and d squared. 9 squared, 9 times 9, 81. C to the 6th squared, use that power of a power rule. Multiply them together, that's c to the 12th. And d squared, well, that's just d squared. That's our area.